Mr. Hanson 414. Make sure that if you're not already subscribed, you are. Make sure that you tell somebody else to subscribe to me because I think this channel is pretty great. You have to let me know. But today, I'm here to help you guys out with expressions. So we've done a lot of work with this. Today, I want to focus on just talking about real world situations where expressions show up so you can understand how to talk about expressions. And when you see something written with coefficients and variables and constants, you can try to make sense of it in a real world context. So that is the focus of today's video. All right, so I'm gonna I'm gonna hang out up here, and I do Link Crew. That's one of my things. I love it. If you have the opportunity as a staff member to get trained, it's a life-changing experience. If you are a student, I highly recommend that you talk to us in the spring and get signed up for it. But we're going to go through a couple of examples today, and I'm just going to show you the power of turning words into math. All right, so obviously this isn't happening anymore, but normally in the school year I sell things. I fundraise for Link Crew, and we sell snacks and things. So maybe one day I'll get to sell you some cucumber lime, the goat Gatorade. But right now, that's off the table. So I'm gonna sell Gatorade. I'm gonna sell it for $2 each. And I've got a lot of old students that just think I'm awesome. So that one of them stopped by, gave me $5. They're like, I see you. I see the mission. So let's just first write the expression. Now, in any expression in math, you have to ask yourself, is there something we don't know? Is there an unknown? And in this case, we don't know how many Gatorades I'm going to sell. So that is my unknown. That means I need to define a variable before I just start throwing letters into the mix. So I'm going to use G for Gatorades, and it's going to be the number. The number, that's not a pound sign. I mean, it is, but, or a hashtag, I should say. Number of Gatorades sold. How many did I sell? How many am I going to get rid of? The real question is, how many are you going to buy? Because got to get the money out your pocket. So we need to write the expression. Well, I know before I sell any Gatorades, I have $5, right? I got $5. I feel like my video's glitching a little bit, so there's some funky stuff in there. My bad. I don't know. These computers can't handle the RAM apparently. Stuff's updating right now, so I might have to go back and edit some of this up. So right now I'm kind of monologuing because I may just be doing this to get myself to edit it out. But if for some case I forget, you get to kind of see how I talk to myself. Win-win. So $5 plus. And now how much are we going to make per Gatorade? Well, it's $2, right? And how do we know how much we make? Well, it depends on how many Gatorades we sell. And right now we don't know how many we're going to sell, so it's an unknown, and that is where we get the G, the Gatorade, the G. Now, here's what you got to make sure you're aware of, how to read that. This 5 is a constant. That means we're going to have $5 no matter what. I could sell 0 Gatorades and still make $5. And this is 2 times G. That 2 is the coefficient. And it's $2 per Gatorade. That per is key. That per tells you that for every Gatorade sold, you're going to make $2. Please try to get this drilled in your brains. We're going to need this a lot. Now, we wrote the expression, how much money will I make if I sold 22? Or I could say I'm going to buy 48, or I'm going to buy 96, or I'm going to buy any number. I could run a bunch of calculations to figure out how much money I can make because I have an expression. That is the power of expressions. It makes work easier, quicker. 5 plus 2. Now, this is where we are going to evaluate the expression. And to evaluate, you need to substitute. So we're going to, instead of writing G, we know what G is. We sold 22 Gatorades. So we're going to put a 22. Parentheses means multiply. So we're going to do 2 times 22, following PEMDAS. And 44 plus 5 equals $49. That's how much money I'm going to make if I sell 22 Gatorades. Now, does that talk about profit? No, because we know that's just the revenue. I'd have to subtract the cost that I spent on Gatorades. But I'm putting some money in Link Crew's pocket. So thanks for contributing, if you've ever contributed. I've got some really cool problems here. I'm not going to talk all about them. But if you want to pause the video and check some of these out, I think you could have some fun with them. This is funny because I've gotten like notices because I got some neighbors that don't buy with me. But I will say that I keep my grass pretty well maintained these days. Not really, but enough to not get in trouble. So let's do this one. I mean, I don't think any trick-or-treating is going to happen this year. I know I've heard some things for trunk or treat, and like Link Crew last year, we did a trunk or treat event, and it was amazing. Um, but I like to pass candy out. I like to go to my older daughter loves just going out, and I like walking with her, especially in our neighborhood. They do nighttime, but again, that might be off the table. So let's just go back to last year. Last year I did pass out candy, and my plan was let me give everybody 3 pieces. Now I like to eat some candy sometimes, so we ate 18 pieces of candy together before giving any to kids. So that's the given, right? Now, to understand a problem, to understand a situation, you got to read into it and say, okay, does this make sense? What's happening? What's important? So I don't even care about this yet, right? Like, leave that alone. What I know now is that I ate 18 pieces. Now, would that be with a variable, or is that just a given? Is that just a constant? I ate 18 no matter what. I could have 0 trick-or-treaters. No kids with their costumes trying to scare me. Down below, comment what you were last year for Halloween. And if you weren't anything, what do you want to be the next time you get to dress up for Halloween? I don't know if I dressed up last year. I think I put on like a Star Wars mask. 18 plus. Now we're passing out candy. So 3 pieces of candy per kid. Well, 3. I don't know how many kids. That is the trigger for writing out a variable and defining it. So kid, I'll use K, but you can use whatever, X, Y. But K is the number of trick-or-treaters, right? Number of trick-or-treaters. And again, you're being exposed to my handwriting, and I am sorry. Number of trick-or-treaters that come to my house. It's important to say exactly what they do. So 18 plus. Now, how can I show that each... Why do I keep these notifications? How do I write this that 3 candies will go to each kid? Well, it's 3 times the number of kids. This is my expression. Easy peasy. Now, this one's fun because I can GCF it, pull the 3 out. I can do a whole bunch of stuff with this, but I'm not. Not today. I really like this vibe with this trick-or-treat emoji. So let's say I'm anticipating 78 kids will come by. How much candy will I pass out? Will I have enough? Will I have enough to eat for myself later is the real question. Let's answer that first question. Well, what would I do? Hopefully, you're starting to see a pattern that once you're given information that relates to a variable, you no longer have a variable. You have something you can substitute and replace for it. So we're going to get 18 plus 3 times 78 because kids was the variable, and now we know how many kids. Pull out your handy dandy notebook or calculator, something to help you do this math. So for me, I'm going to bring down the 18. I like to multiply, I really do. So I'm going to break this up. The way I do it is I do 70 times 3 and 8 times 3, and then add them together. That's what my brain does, at least. So 70 times 3 is 210. 3 times 8 is 24, so that's 234. 234 piece of candy. Sam's Club. Costco. I've never had a Costco membership. I let my Sam's Club one run out because I haven't really been there since Corona. Dang, I got to return something there, actually. Add 18 to that. If I add 20 to that, that'd be 254. Take 2 away. That's 252 pieces of candy that I would pass out. I think that's a pretty good day. Now, what if I bought a bag of 300, right? And I ate my 18, but I'm like, ooh, I got to keep this figure. I don't want these shirts not fitting me. How can I ensure that I'm not going to have any leftover candy? I want to pass out all of the 300 pieces. Well, we just can do the same thing and kind of work backwards. Now, I don't want to get into this too much. I'm going to go over here, actually, because we're not into equations, though we're getting there. So you could just guess and check. Well, you could say, okay, 78 kids took me to 252. So you could be logical and be like, well, what about 85? What about 90? What about 100? Well, 100 would be too much because I already ate 18 pieces, so it's not 100. So you can just guess and check. Guess and check is a valid mathematical strategy. It might not be the most efficient, but it works. So for me, what I would do is I would set up an equation. And again, this is a little bit beyond what I wanted to do, but I want to always drop knowledge when I can. So we get 300 equals 18 plus 3K. This is my expression for the number of candies I'm giving out, and the 300 is how much I want to give out in total. So now I'm going to solve this equation. This is my first time solving equations this year on camera, I think. We're going to subtract 18 on both sides using the subtraction property of equality because we're trying to isolate the k and get it by itself. So this is going to be 282 equals 3K. I always split that railroad track and make sure that everything's nice and neat. Now we're going to divide both sides by 3 to undo that multiplication using the division property of equality. Those were simplified to 1. And then K is going to equal, well, 282 divided by 3. I know that 300 divided by 3 is 100. 18 is what's the difference there. So 18 divided by 3 is 6. So I can take 6 away from 100 to get 94. So I need 94 little kids to come to my house and get some candy. Now, if you're ever in the airport area in Milwaukee and you want to try to find my house and get some candy on trick or treat, please do. I would love to give you some. Be a Power Ranger. Shout out, I don't know what series this is. I'm telling you, I used to be a huge Power Ranger fan back in the day, though, with the originals. And then, like, when they had the movies in the 90s, I got some Power Ranger stuff somewhere. Let's throw a mask on, guys. We should have a costume day in class. Let's do it. Another problem that I'd like to look at. So, you guys know I'm a huge basketball fan. I coach basketball. I should put them on my channel. They're my daughter's channel. All her games. And I think for little kids were pretty nice. But, we got the Heat versus the Lakers. And, we could have something that, is Jimmy from Marquette Buckets numbers, right? Him and Hales Corner's hero. I put that out into the world today. That's what it's gonna be. So you can have something like this where it's like, and again, forgive me, Jimmy, I don't have your numbers in front of me, so I'm gonna just make some guesstimations right here. We got 24.2p. We could have something like 9.6r. We could have something like. Now, the question would be, what does this expression represent? Obviously, these are not like terms because there's different different letters. So we would have to establish that P represents points per game in the finals. And on that same note, R would be rebounds per game, and A would be assists per game because he's putting in work. Sadly, I don't think Miami's going to be able to pull it out. I think if they had a healthy team, it would have been an interesting series, although I think, LeBron just gets calls that no one gets. He's allowed to do a lot more. So not hating on him, just I think that's definitely true. And Jimmy Butler got a little apprehensive in the end of the last game. So breaking down things like this, that's a totally valid thing. You could have something like, to calculate the amount of points, you'd have 2s plus 3y plus 1f. And this could be an expression to calculate how many points per game somebody scores. And you could have s be 2-point shots made. And you could have the Y be 3-point shots made. And you could have the F be free throws made. And then getting a little sloppy here, but it is what it is. So we could say, okay, this person made 7 2-pointers, 3 3-pointers, and 5 free throws. How many points did they score today? Well, we can plug it into our expression. So 2 times 7 plus 3 times 3 plus 1 times 5. We get 14 plus 9 plus 5, which is 28 points. And that's how many points they scored in that game. So just knowing, I think the biggest part of this is being able to write an expression from something. So identifying that variable and defining it. And then if you're presented with an expression, break it apart. What are the terms? What are the constants? What are the coefficients? What does everything mean? And that's going to help you with modeling and, application problems just in general. So I think that's huge. So again, the NBA season's coming to an end. Bucks are getting it next year. But that's expressions for you guys. So I'm always down, guys, to do more. If you need more things, let me know. But in honor of the Power Rangers, hit me a favor. Hit that subscribe button. Like this video. Like all my videos. Share this out there. We worked on expressions today. And, I'd love to hear from you. So drop down some things below. Maybe tell me what your favorite Power Ranger was. Your favorite Power Ranger series was. Maybe you don't like Power Rangers. Tell me that too. Let's get active so I can get this channel popping. And again, That's at Mr. Hanson 414. I will see you later.